Planning is an essential tool for the preservation of the forest as an asset. It is crucial to come to valid, long-term sustainable decisions when making interventions in the natural environment. Due to environmental and conservation issues, large-scale forest management also requires a substantial amount of spatial data, which is difficult and time-consuming to obtain. This is assisted by Arial remote sensing, an easily employable, extensive and detailed observation method whereby aerial images of the observed huge areas are converted into maps. Mecsekerdo Limited and its partners launched a project in 2017 called RedFaith in order to create maps and acquire thematic data by aerial mapping, with the result of a composite picture of the quality of certain forest areas. The retrieved information that can be analyzed from several angles helps reach valid decisions regarding forest management, in particular with respect to the dangers of spreading invasive species and the effects of possible interventions. Invasive non-native plants pose a major threat to biodiversity. Foresters require accurate and current spatial information to be able to localize small-scale infections to effectively treat them before they become too widespread. Spatial information is essential to devise and implement strategies aimed at plant management, and it also ensures the effectiveness of procedure supervision. The project affected 30% of the forest managed by Mecsekerdo Limited. The 15,000 hectares of designated areas in Baranya County are situated northwest of Pécs in the Forest Management Division of Sásd, Hetvehely and Szigetvár. The surveyed areas comprise approximately 5,000 forest parts incorporating mainly deciduous species of various age and composition. The technical devices used to undertake the surveys are outstanding and state-of-the-art, even judged by the European standards. Aerial surveying was divided into two parts during the planning of the project. One of them focused on the winter period, when photographs were taken of the leafless state using aerial laser scanning and digital measuring cameras, which helped to acquire detectable data about the soil surface, the lower canopy, and the trunks of the trees. The LiDAR surveys were conducted by using a Regional LMSQ780 high-performance laser scanner. Part of the system included a high-precision IMU system capable of capturing the position and in-flight, three-axis motion of the aircraft. LiDAR is an active remote control technology which can collect large amounts of data in a very short time period. The basic principle of the measurement is the following. The sensor emits a laser beam towards the Earth's surface, and by measuring the reflection time, it can calculate the distance. As a result of a precise navigation system, the coordinates of the reflection point can be determined by the exact location and the position of the sensor and the measured distance. The advantage of the aerial LiDAR is that it is capable of precise and fast data collection about the surface of the Earth over a large area, and in addition, it can be used in areas where ground measurements would require considerable resources. The point density of laser scanning imaging facilities considerably detailed spatial analysis. It can be used to construct terrain and surface models, determine tree height, and in the case of an older forest stand, the size of the canopy and the number of trunks as well. The aerial hyperspectral survey was performed with the help of an Asia Kestrel 10 type device, which is a type of push-broom scanner sensor capable of capturing high spectral range images with a width of 1020 pixels. In addition, aerial photographs were taken specifically with a Hasselblad A6D medium format 100 megapixel camera system built on a shared platform with the hyperspectral system. Hyperspectral remote sensing can capture the various spectral characteristics of materials. The spectral characteristics of certain materials, objects and plant species are basically like fingerprints. Each material, tree species, has a unique spectral curve. So trees communicate through colors as well. Green foliage has shades which, by simply looking at it, the human eye cannot detect. The sensor, on the other hand, can detect the whole spectrum and the various shades of a European oak tree or an ailanthus. In fact, it can distinguish between healthy and sick leaves as well. Following the aerial imaging, the result of the most precise pixel-based classification obtained from the hyperspectral survey was combined with the foliage model created via the LiDAR laser-scanned point cloud. The result of the data processing and image analysis is a vector graphical, individual-based, thematic tree-species map containing the letter and the color code of the tree species, classified into the particular canopy types according to an attribute sheet. In the case of tree species maps created from the hyperspectral data, the accuracy of location review concerning invasive tree species over 10 meters in height, such as the ailanthus and the false acacia, was carried out by the field measurements. The measurements were taken by experts from Mecsekerdo Limited and EnvironSense Hungary Limited. To perform the measurements, the forestry and the contractors alike used global navigation system with submetric precision capable of real-time correction. A total of 755 tree coordinates were recorded during the survey. A 5-meter circle around the field position of the individual trees was intersected with the vector graphic tree species map, and the correspondence between the measured individual trees and the ones on the map was examined. The project has demonstrated that forestry requires comprehensive remote sensing data, which facilitates monitoring any changes in biodiversity and surveying forest health. Foresters have been able to gain experience with special devices and technologies regarding next-generation hyperspectral and LiDAR data processing. The project has managed to confine a continuous invasive ailanthus population in over 1.5 acres, precisely with the help of those innovative technological methods that were previously successfully used in the Croatian-Hungarian cross-border project called Oak Protection. Mecsekerdo Limited, together with its partner performing the Arial survey and data processing, have organized several professional events, the purpose of which is to share surveying experiences, hoping that it might contribute to the dialogue between professionals in the field of geoinformatics, especially those with a professional interest in remote sensing. The event, embedded in forest school activities, might inspire future geoinformatics professionals and forest engineers to take the first step towards an exciting career. The raw data and the partially processed data of surveying will also be available on request for educational institutions, nature conservation organizations, and various authorities.